Greeting grade 12. Today with you are with Zazibiela, and I will be teaching you guys, or will be doing a revision on how to answer problems on mathematics paper 1. So here we'll be working with exemplar taken from 2014 on one of the national senior certificates of which is CAPS, Educational Department of Education. Okay, this is the problem that we are faced with today. We are required to solve for x. How do we solve for x in this case on question 1? The question says that, okay, we have 1.1. We are required to solve for x. And then 1.1.1. What is the problem? We are given 3x squared minus 4x is equal to 0. So to solve this one, we are going to use a common factor method. If you can take a closer look here, we have something that is common, of which is something that is here and also here. What is it that you see here that is also here? It's a variable x. So if I factor out a variable x, I'll remain with what? With 3x squared minus 4x. Pay attention, if you factor out, you also divide by the factor everything that is within the bracket. So divide by x, both sides, is equal to 0. And then now you have x. When you divide both sides by x here, you'll be having 3x minus 4, of which is equal to 0. So the only situation or the only condition that can make this statement true, it's either x has to be equal to 0 or this 3x minus 4 has to be equal to 0. So what do we mean? We mean this statement will be true if and only if x is equal to 0 or 3x minus 4 is equal to 0. We are required to solve for x here, so it will be 3x equal to 4, divide both sides by 3, then x is then equal to 4 over 3. Then we go to 1.1.2. Given x minus 6 plus 2 over x is equal to 0. And we are told, we are given a condition that x cannot be equal to 0. We know that whenever we divide by 0, we get undefined on our real line. Since we are working with the real values here, we can't use x as, we cannot divide by 0, in fact. So here we are required to leave your answer. You are required to leave your answer into correct into 2 decimal. So if you are told that you have to leave your answer correct into 2 decimal places, you are then permitted to use a quadratic equation. But if you take a closer look here, this is not in a quadratic format. So before you tackle this problem, you have to make sure that you get rid of the denominator. So in most cases, when you have denominator in your expression or equation, try to make sure that you get rid of the denominator and then solve for the equation. So how do we eliminate this denominator? By multiplying with x throughout. So here, this is what will be happening. I will multiply by x everything here. It will be x minus 6 plus 2 over x which is equal to 0. So times x again. What I do on the left, I also do on the right. So when I multiply by x here, x times x becomes x squared. X times minus 6, it's minus 6x and plus. So here, this one will multiply this one to be 2x over x. So that is why I'll end up with 2 being equal to 0 times x is 0. Now I have an equation or a quadratic equation that is on a standard form. So the fact that now my equation is on a standard form, I can then now label the value of a to be 1, value of b it's minus 6, and the value of c is equal to 2 in this case. So what is next? I go to my formula sheet. This formula will be provided to you, so you don't even have to memorize it. Quadratic formula, which is x is equal to minus b is plus or minus square root of b squared minus 4ac divided by 2a. Okay. So now what is negative b? Please guys, make sure that when you have negative into something, make sure that you plug your value of b inside the bracket, so that whenever you have a negative sign will be multiplied by this one and then get a positive sign. Because most of people just make such mistake of avoiding to put this thing on bracket. So it will be minus into minus 6 plus or minus a square root of what? Into minus 6 squared minus 4. The value of a is 1 and the value of c is 2. Then you divide by 2a. So it will be 2. The value of a is what? Is 1. So if you can take a closer look here, when you multiply the 2, you get positive 6 plus or minus square root of what? This one will be 36. Negative 6 squared is 36 minus 4. 4 times 2 is 8. And then you divide by 2. Divide by 2. Okay. Then from here, if you can take a closer look here, we have plus and minus, meaning the first value will take plus. So here, if you have 36 minus 8, 36 minus 8 is equal to 28. 28. Okay. 28 over 2, or x is equal to 6 minus square root of 28 over what? Over 2. So now this is what you have. Then what is next? X, remember that the statement say correct to 2 decimal. So this one is same as 6 over 2 plus, here it's 7 times what? It 7 times 4 divided by 2, or x is equal to 6 divided by 2, using the knowledge that you learned of dividing a binomial by a monomial. So here 28 can be written as 7 times 4 again. Then you divide both sides by 2. So now you have x is equal to 6 divided by 2, it's 3, plus here you know that the square root of 7 is rational, but square root of 4 is rational. 2 divided by 2, or x is equal to, here it will be 3 minus square root of 7 times square root of 4 is 2, and then divide both sides by 2. So this and this cancel, this and this divide. So you end up with x being equal to 3 plus square root of 7, or x is equal to 3 minus square root of 7. The question is, Did we answer the question? Unfortunately, the answer is no. Why not? It's because we have not yet left the answer correct to decimal. So if you leave your answer like this, you won't get the final mark, because the final mark requires you to leave this in decimal, and they said correct to decimal. So this then implies that the value of x will be 5,65, or x will be 0,35. So this is now rounded up to the nearest. So these are the possible solutions for x. Okay, I hope I was not too fast. So if you happen to find out that I was too quick, make sure that you pause the video, and if you want to access this note, you can even write on chat. I will make them visible for you. Okay, we then move forward to 1.1.3. 1.1.3. 1.1.3 says that I have x to the power of 2 over 3 is equal to what? Is equal to 4. I have and this is a power function. So I want to rationalize, I want to eliminate this exponent. How do I get rid of this exponent? By rationalizing, it's whereby I try to eliminate the exponent that is in a fractional form. So this will be same as saying x is to the power of 2 over 3 times 3 over 2. So what I did on the left, I have to do it also on the right. So it is same as 4 here. Now it will be, you know that any number has an exponent of 1 divisible but divided by 1 multiplied by 1. So in this case here, it's 4 to the power of 1 times 3 over 2. So now this one becomes 2 times 3, it's 6. 3 times 2 is 6. And now you see, now I have 4 to the power of 3 over 2. And it's so unfortunately that it is going to cause a problem for me to solve this. So I have to try by all means that I want to simplify it such that it does not cause any trouble on my side. So 6 over 6 is 1. So x is equal to what? I can rewrite this as 2 to the power of 2. It is not mandatory, but I just decided to write it like this so that I can avoid having an exponent that is a fraction. So it is 3 over 2. So you see now x is equal to, you see now this one will then divide this one. I end up with 2 to the power of 3, of which is something that now I know of. So my value of x will then be equal to 8. So I hope I didn't lose you guys anywhere. Let us continue. Now we are on 1.1.4. So on 1.1.4, this is what I'm given. I'm given that 3 to the power of x into x minus 5 is less than 0. So if you can take a closer look here, when we say it is less than 0, that means the result has to be what? To be negative. Okay, if this result has to be negative, we know that we only obtain negative because you see now I'm multiplying these terms. So I'm multiplying this one by this one. So by multiplying this expression or this equation, unfortunately it's not equation, it's an inequality. So for me to get a negative result, I have to multiply negative times what? Times positive. So what does that mean? It means one of the two has to be negative for this condition to be true. But if you can take a closer look here, let us start with 3.3 to the power of x. If you can look carefully here, whatever value of x that you can plug in here, it will never make this term negative. I'm not sure whether you hear me. My argument says whichever value that you can plug here of x, it will never make this term negative. So as the result, x to the power of 3 has to be positive, and x minus 5 is the one that has to be negative. What does this mean? It means that when I multiply a positive term by a negative term, that is the only case where I will get a negative sign, of which is something that's less than 0. Hence, I will be having x minus 5 less than 0, implying that x has to be less than 5 for this condition to be true. By being less than 5, if you can take any arbitrary value, even 4,99999, and plug it here, you will get a negative number. And whenever you multiply a negative number with a positive number, that is the only condition whereby you will get the value that is less than 0, or the value that is negative. So in this case, this is your result. X, 3 to the power of x will be greater than 0, or x will be less than 5. So this is the only condition that will make this statement be true. I hope I managed to explain this to the fullest. Right, now we are continuing. We now going to 1.2. We are done with 1.1. So in 1.2, we are required to solve for x and y simultaneously. So how do we solve for x and y simultaneously? In this case, we are given two equations. Equation number 1, of which is this one, and equation number 2, of which is 2x minus y is equal to 2, which is equation number 2. So in this case, if you are required to solve such, we are now going to add our equation number 3. So equation number 3 will come from choosing the equation that is not complicated. So this is the equation that is not complicated. If I can make y subject to the formula here, I can then get equation number 3. How do I make y subject to the formula? So here, by transposing 2x, taking 2 from right hand side to the left hand side, it becomes negative minus 2 is equal to y. So this is equation number 3. So now, what is it that are we going to do now? We are going to substitute equation number 3 into equation number what? Equation number 1. So how do I do this? Where I see the value of y, I plug 2x minus y. Why do I do that? I'm trying to reduce number of unknown variables, because if you can look here, y is an unknown, x is an unknown. So x is an unknown, y is an unknown. So by writing these things in terms of x, that means I'll be having only one unknown. So you see here, if y is represented by 2x minus 2, that means wherever I see y, I will plug what? It's 2x minus 2 equal to x squared minus x minus 6. So now if you can take a closer look, the only unknown variable that is appearing here is x. Y is no longer popping up. So by solving for x, that will then assist me in order to solve for y. So this is what I have. I want to write this in a quadratic formula, quadratic equation in fact. So taking this one to the other side, I will end up with x squared minus x, 2x to the other side minus 2x, minus 2 to the other side minus 6, plus 2 is equal to 0. So now I have x squared minus x minus 2x, it's minus 3x, and then minus 6 plus 2, it's minus 4, equal to 0. So here I want to find factors such that when I multiply them they give minus 4, and when I add them they give what? Minus 3. Pay attention here. When we are factoring this, we have x and we also have x, which is equal to 0. So factors, when you multiply them, they give you minus 4, but when you add them, they give you minus 3. What are the factors of minus 4? Factor number 1, first one, it's minus 2 times 2. Okay, it's give minus 4, but minus 2 plus 2 is not equal to minus 3. Okay, that means this one out. Then let us go for the other one, the second one. If you say minus 4 times 1, you get minus 4. Tick. Okay, minus 4 plus 1, you get minus 3. Oh, tick. So meaning we take these factors. Okay, let us erase others. Okay, now erasing all of them. So it will be minus 4 and what? And plus 1. So it will be minus 4 here and plus 1. So x minus 4 is equal to 0, or x plus 1 equal to 0. That is the only condition that can make this statement be true. If you multiply any number by 0, that is the only time when you get 0, when you're multiplying expressions or numbers or variables is. So this then implies that x is equal to 4, or x is equal to minus 1. So these are the values of x that I have. Now, how am I going to get the values of y using these values? Go back. You know from equation 3 that 2x minus 2 is equal to y, meaning you can replace x by 4 and replace x by what? By minus 1. So you have y is equal to 2x minus 2. So now for x that is equal to 4, this is what you'll get. Y will then be equal to 2 times 4 minus 2. Okay, of which is 2 times 8. It's 8 here minus 2, and the answer will be 6. So we'll be having a coordinate here that says 4 is to 6. Again, for x that is equal to minus 1, I'll be having y is equal to we have 2 instead of x. I plug minus 1 minus 2. So here it will be minus 2 and minus 2. The answer will be minus 4. Yes, when you plug minus 2 here, minus 2 minus 2, it will be minus 4. So as the result here, it will be in a coordinate form. Minus 1 is 2 minus 4. And I hope was clear. If you feel like there is something that was too fast in, please make sure that you pause the video and you revisit that section. Now we're going to move to 1.3, where we are required to simplify without the use of what? A calculator. 3 marks question. Okay. Okay, 1.3, simplify without the use of a calculator. Okay, what is given to us? We are told that, okay, I'll use this one. We are told that a square root of 3 times the square root of 48 minus 4 to the power of x plus 1 divided by 2 to the power of 2x is same as what? Okay, there's nothing that you can do with the root 3 times it as 16 times 3 minus, if you can take a closer look here, for me, in order to use some laws of exponent, because I see that I'm working with powers now, né? So there's a base and exponent. I can rewrite 4 as a power of 2 to the power of 2, okay, x plus 1 divided by 2 to the power of 2x. So now here I'll be having a square root of 3 times, and square root of 16 times square root of 3 by using laws of or rules of multiplying sets. So here I'll be having 2 times x, it will be 2x plus 2 all over 2 to the power of 2x. Okay, then from here, I know that square root of 16 is a perfect square and it gives me 4. So I'll be having 4 square root of 3 times square root of what? Of 3 minus. So now I have powers of the same base. Can drop one base and subtract their exponent. So I have 2x plus 4, not plus 4. What do I take 4 from now? Okay, not plus 4, but it has to be what? A plus 2 minus 2x. Okay, so from here now I'll be having 4, and then when I multiply the 2, I will get what? I will get, remember, square root of 16 is plus or minus 4, it's fine. It's plus or minus 4. Here when you multiply the 2, it's plus or minus. When I multiply the 2, I get plus or minus 3. So minus what? 2, and then the 2 cancels, 2 to the power of what? Of 2. So if I pick positive, so if it's positive, 4 times 3, because these two will just multiply, positive, gas, positive, negative times negative, give us what? Positive. So as a result, you'll end up with positive 4 times positive 3 minus 4. So it will be just 12 minus 4, and the final answer will be 8. Look here, 1.4, okay, 1.4.1. The equation is written in a quadratic equation, and it is in a turning point form. We know that if we have f at x being equal to a into x minus p squared plus what? Plus q. Okay, the equation is written in a turning point form, okay, where your turning point is p to q. But in this case, we have f at x is equal to 3 into x minus 1 squared plus what? Plus 5. So your turning point in this case is what? Is 1 is to what? Is to 5. Okay, look carefully now. So if y is equal to 5 is the turning point, okay? Again, look here, the value of a is greater than 0. So you have two conditions now. Your turning point is 1 is to 5, meaning the highest value or the lowest value. That means your y will be greater than or equal to what? to 5. You see? So this is your range. And in this case, you have g at x, which is equal to 3. So if you can look here carefully, the graph of f at x only caters for values they're starting from 5 upward. Not for 3. 3 is below than 5. So your graph will look like this. I want you to visualize whatever that will be discussing here. Okay, so look carefully here. This is your y-axis. Okay, it's your x-axis, sorry, this is your y-axis. Okay, look now. So this is what we are referring to. Okay. Okay. Yeah, the points, scale. So it is 1, 2, 3, 4, 5, 6, 7, and 8. So here we have 0, here we have y, minus, x, sorry. It's minus x, it's minus y. Okay. We have minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Okay, we have 1, 2, 3, 4, 5, 6, and 7. Minus 1, minus 2, minus 3. I know that whatever that I'm writing here is no longer needed, but I just want to write everything in order to make my Cartesian plane look formally. Okay, so now look at what I'm referring to now. Look carefully. This is the line g at x. This is the line g at x. This is the line g at x. And now, take a closer look here now. Okay, look here. Okay. Okay, so now here is the point. This is the point, of which is the turning point, and the y-intercept will be what? X, where x is equal to 0, so it will be 8. So this is my graph. So if you can look carefully here now, how can it be possible for f at x to be equal to g at x? This is f at x, this is g at x. So the question is it possible for f at x to be equal to g at x? Nope, it's not impossible. No. No, the reason why it's because the range for what? For f at x says y is greater than or equal to what? 5, while g at x is equal to 3, and 3 cannot be equal to 5. So that is what was required. You can just construct it with your own English parts. I was just trying to make sure that I make you visualize whatever that I'm referring to. Apologies, my graph is not drawn to scale, but I was trying to emphasize the point. Y f at x cannot be equal to g at x. I hope I gave it a fruitful response or evidence. All right, now I want us to look at this one, 1.4.2. So here we are required to determine the value or values of k for which f at x is equal to f at x plus k, which has 2 unequal real root and 2 marks. Again, here there are 2 ways you can use a visualization. If you can look carefully here, you see that the range for f at x So range of f at x, say it's greater than or equal to what? Or equal to 5. Okay. And then g at x here is equal to what? Is equal to 3. So the only value of k that can make f at x be equal to g of x plus what? Plus k is same as saying, you know that your f at x is 5 and your g at x is now 3 plus what? Plus k. You see? So transposing, it will just make your k to be equal to 2. But we are not going to use this method because we are required to do what? We are required to work with the knowledge of nature of fruit. Okay, but just from your visualization. So now you have in mind that we want our k to be equal to 2. Okay, how can we solve this problem without using that shortcut method? Okay, 1.4.2. It says that determine the value or what? Or values of k for which f at x will be equal to g at x plus k, which has two unequal real roots. Okay, let's just try to dive into the solution for this. 1, we know that f at x is equal to 3 into x minus 1 squared plus 5. And now we know that g at x equal to 3, meaning for f at x, I have to write f at x in a standard form. Okay, it will be 3 plus k now in this case, because sorry, it will be just 3. Be not confuse the two. Okay, it will be 3. So now look at what I will be doing now. F at x, I want to write it in a standard form. 3, okay, x minus 1, x minus 1, so plus 5. So in this case, we want to use an algebra to solve for k. We want to solve for k algebraically, unlike the way that I used it by just helping you visualize the graph that I drew for you. Okay, so 3 here will be having x squared minus 2x plus 1 plus 5. So as the result, you have 3x squared minus 6x plus 3 plus what? Plus 5. So you end up with 3x squared minus 6x plus 8. Okay, so this is the f at x. This is f at x. Okay, g at x. Okay, I know g at x is equal to 3. So now when I equate f at x with g at x plus k, I want to solve for k now. I'll be having 3x squared minus 6x plus 8 equal to 3 plus k. So as the result, I'll be having 3x squared minus 6x plus 8 minus 3 minus k equal to 0. And then from there, I'll be having 3x squared minus 6x, 8 minus 3, I get 5 minus k is equal to what? 0. Okay, so from here, I now use the properties of nature of root. They say there has to be non-equal, meaning my discriminant has to be greater than what? 0. What is the value of discriminant? My discriminant is equal to b squared minus 4ac, of which is something that has to be greater than 0. So b squared in this case, my a is equal to 3, my b is equal to minus 6, and my c is the constant. The constant in this case is equal to 5 minus what? Minus k. So in this case, I'll be having b squared minus 4ac greater than 0, where b is equal to minus 6 squared minus 4, and a is 3, c is 5 minus k. It has to be greater than 0. So here it will be 36 minus, so here I'll be having 12 with the 5 minus k. It has to be greater than 0. So look carefully now, I'll be having 36 minus what? When I multiply the two, it will be 60. Multiplying with that one, it will be plus 12k. It has to be greater than 0. So in this case, I'll be having what? What are you doing now? You're disturbing me right now. So what I'll be doing now, when I minus the 2, I'll be having 24 minus 24. Yeah, minus 24 is correct. Plus 12k is greater than 0. Taking this one to the other side, I'll be having 12k greater than 24, divide both sides by 12. So my k has to be greater than or equal to, but it can be just greater than equal to 2. Yeah, because if I'm looking at the point whereby k is equal to 2 exactly, my graph will be 3 plus 2, and it will be here on my turning point. You see, yeah, it will be here on my turning point. That is where f of x will be equal to glx plus k. So it's greater than or equal to. Yeah, greater than or equal to. I hope this video was productive. Should you have any queries, please don't hesitate to write in the comment section. I will then respond based on your queries. But at the moment, I will then come back with question 2. So if you need this document, please make sure that you write in the comment section. I will then share the document with you.